What are the chances of one event happening, given that we already know another event has occurred? That's where conditional probability comes in. This fundamental concept is the backbone of many machine learning models, especially those used for predictions and decision-making. Welcome back to Knowledge Academy's YouTube channel. In this video, we'll break down conditional probability in simple terms, explain its importance in machine learning, and go through some real-world examples. In Part 2, we'll dive into Python and implement a Naïve Bayes spam classifier using conditional probability. Before we jump into machine learning applications, let's first understand what conditional probability means. It refers to the probability of an event occurring given that another event has already happened. Mathematically, conditional probability is written as shown, where PA by B is the probability of event A occurring given that event B has already occurred, whereas PA intersection B is the probability that both A and B occur together, and PB is the probability of event B happening. Let's take a simple example. Let's say you're at a party and 40% of the guests are wearing glasses. Out of all the people wearing glasses, 25% are also wearing a hat. Now, if you randomly pick someone wearing glasses, what's the probability that they're also wearing a hat? Using this formula, as shown, we can find it in no time. Here, since we know that 25% of the glasses wearing people have hats, the conditional probability is 0.25 or 25%. So, this is how conditional probability works. It adjusts our probability based on what we already know. Now let's understand why conditional probability matters in machine learning. Conditional probability plays a critical role in many machine learning algorithms. It helps models adjust predictions based on new information. Instead of treating events as independent, conditional probability allows models to consider dependencies between different factors. Here are a few examples of how it's applied in machine learning. First, in spam detection model, imagine you're building a spam filter. You want to predict whether an email is spam based on certain words appearing in it. So for this, we ask key question, like given that the word free appears in an email, what's the probability that this email is spam? Now, this is exactly how the Naïve Bayes algorithm works. It calculates the probability of an email being spam based on the presence of specific words. Next is medical diagnosis. Conditional probability is also widely used in medical AI systems. Here we ask questions like, what's the probability that a patient has a disease given that they tested positive for a symptom? This helps doctors and AI models assess risks and improve diagnoses. Next, it is used in predictive text and chatbots. Ever wondered how Google autocomplete or chatbots predict what you'll type next? They use probability models that estimate, given the previous words in a sentence, what's the probability that the next word is X? This allows AI-powered assistants to generate more natural and relevant responses. Now, how does conditional probability work in machine learning? One of the most well-known algorithms that rely on conditional probability is the Naïve Bayes classifier, which we have learnt about in the previous video in this machine learning playlist. Naïve Bayes is a machine learning algorithm that applies Bayes' theorem with an assumption of independence between predictors. It works by calculating the prior probability of each class, then computing the conditional probability of each feature appearing in a given class, using these probabilities to classify new data points. For example, in spam detection, probability of spam by word free is equal to probability of an email being spam given that it contains word free. Then probability of not spam by word free is equal to probability of an email being not spam given that it contains word free. The classifier compares these probabilities and decides whether to classify the email as spam or not. So in a nutshell, conditional probability helps us update our understanding based on new evidence. That is why it is widely used in machine learning algorithms like Naïve Bayes, Bayesian networks, and more. Whether it is for spam filters, medical diagnosis models, and predictive text AI, they all rely on conditional probability. That's it for the introduction on conditional probability. I hope you got a gist of what conditional probability is. Now in Part 2, we'll get hands-on and build a spam email classifier using Python and scikit-learn. We'll implement the Naïve Bayes algorithm step by step so you can see conditional probability in action. Make sure to like, share, and subscribe so you never miss an update. See you in Part 2.